My name is Moszkowski. I'm a research analyst at the New York Fed. And my team, the DSGE team, released a package called DSGE.jl in December. So that's what I'm going to be talking about today. So I've said the letters DSGE a lot already. What is a DSGE model? It stands for Dynamic Stochastic General Equilibrium, which is a lot of big fancy words. And what it really means is that we have this structural model of the macroeconomy that's useful for four main things. First, forecasting macro variables like GDP and inflation, interest rates, all that good stuff. Understanding the forces that drive the economic outcomes that we observe. So, for example, what is the reason that we see low interest rates? Or what is the reason that we see inflation at the level it is? And that's the questions that we can answer with a DSGE model. So we produced this package called DSGE.jl. What does it do? It mostly just estimates and solves DSGE models. We can use it for forecasting. So why are we using Julia at the New York Fed is probably a fair question to ask. So the DSGE team has existed at the Fed for about 10 years. And for most of that time, although there are other software, there is software out there for solving DSGE models, we developed completely our own code base in MATLAB. First of all, MATLAB, we were kind of running up against the what was possible to do in MATLAB. One of the things that my economists have been wanting to do for a long time is start using a nonlinear model. Our model is very linear. It has one nonlinearity. But if we wanted to add more nonlinear features, we just couldn't do it in MATLAB. We didn't have the performance that we needed. Why are we using Julia? Primarily, the type system and multiple dispatch are two things that actually really support economic intuition. And that was kind of the most amazing thing to me when I started working with Julia, is that, wow, programming language features can support economics. That's so cool. And then, of course, we rely on the JIT and the compiler to do the heavy lifting for us. Just to give you a sense of how much easier it is to manage our code, we have about half the number of lines of code in the estimation step as we did in MATLAB. And in general, our performance overall is about 9 times as fast as it was before. And another big reason that we have this, basically the main reason that we have such a huge performance improvement is that we're using types all throughout the DSGE.jl code base, which is not a surprising thing to say in this room, but it is a very surprising thing to hear if you're an economist and you don't know what types are. So we had to do a lot of, we actually ran a seminar at the Fed, what are types, what is Julia, how do you define types, and it was really exciting to be able to talk to people about how you turn an economic concept into a data structure. Okay, so ongoing work as we're working on the forecasting step, which I think is the last big piece. Plotting is going to be hopefully really simple, and we're excited to use all the proper plotting infrastructure that's out there. Long term, we'd hope to get in some of these nonlinear solution methods like I talked about earlier. That's basically it. Yeah, so thank you, and check our GitHub.